Alright, so today we are going to continue on with quadratic functions, but we're going to focus on increasing and decreasing intervals of quadratic functions as well as minimums and maximums. Before we do that though, we need to recall domain and range. So remember, domain is all of the x values of a function, and when I say x values I should specify we mean inputs. Because remember, we don't have to have x, it could be some other variable, but we mean the input, so all of the possible inputs of a function. When we look at a graph, we read from left to right. So when we read the graph from left to right, that tells us the domain. The range then is all of the possible y values or outputs. And for this, when we read the graph, we read it from bottom to top. And just to emphasize, for both the domain and range, the reason why we read from left to right for the domain or bottom to top for the range is because we always want to go from lowest to highest, right? And so that's how the x values go from lowest to highest, is from left to right, and how the y values go from lowest to highest is bottom to top. Okay, so next thing, I want you to try and do this. Just draw two different graphs that you would describe as increasing over the entire domain. So that means that the entire graph is always just increasing. So draw what you think that would look like. Two different graphs. Pause the video, do that, unpause when you're ready to discuss. Okay, so I actually drew three graphs. I'm a little bit of an overachiever here. I know everybody loves an overachiever, but because I wanted to give a couple of different examples. So the first one I drew here, this is what we call a line, hopefully, and that is what I would describe as increasing the entire time. The second one here, we haven't talked about this yet in this class, but this is what we call an exponential function, or that's what it's supposed to kind of look like. But anyway, again, it's increasing the entire time. And then the third one here is kind of like what is called a log function, which again we have not done in this class, but it's a curve that is increasing the entire time. So now I want you to draw two different graphs in which you would say the curve is decreasing the entire time. So pause the video, do that, unpause when you're ready to discuss. Alright, so again here I drew three graphs, but they are similar to the graphs I drew before for increasing, and this gives us a little bit of conversation to discuss, well, what makes it increasing versus decreasing, because maybe you could argue either way, but maybe you can't. So here again I drew a line. This is what we would call decreasing the entire time. Here I drew a curve that, again, I'm saying it mimics like an exponential function, but if you don't know what that is, that's fine. It's still a curve that's decreasing the entire time, and here my green curve is also decreasing the entire time. So let's look at these, increasing versus decreasing. What makes it increasing versus decreasing? And this is where we have to have some orientation of, well, I could argue, maybe that this red graph here is increasing because look, it's going up as I go to the left. It's going down as I go to the right. And so that's where we have to have some standardization, and the standardization with mathematics or algebra, when we talk about increasing versus decreasing, has to do with our domain, which is always read from left to right. And so that's how we refer to increasing versus decreasing as well. So as I move across the curve from left to right, am I going up or am I going down? And if I'm going down, then that's what we call decreasing. And if I'm going up, back here, then this is what we call increasing. So we always have to be looking from left to right when we're talking about increasing versus decreasing. So as you go from left to right, are the y values going up or are they going down? Just to confirm that, I want you to try to draw two different graphs that you would describe as increasing over part of the domain and decreasing over the other part of the domain. And then I want you to try and identify which intervals are increasing and which are decreasing. Pause the video, draw graphs, unpause when you're ready to discuss. Alright, so here I drew two different graphs, and maybe yours look different than this. So this one is supposed to look kind of like a parabola, and here on the left hand side it's decreasing, and then on the right hand side it's increasing. Here this is supposed to kind of look like an absolute value graph. On the left hand side it's increasing, and then on the right hand side it's decreasing. Now, this is where I really want you to pay attention to, because one of the challenges that we're going to have with this is arrows. Arrows seem to always just throw us off for some reason. So a lot of times somebody might look at this graph and say, oh, well, it's just increasing on both sides because the arrows are going up on both sides, right? Or this graph because the arrows are going down on both sides, so it's decreasing on both sides. But it's not. Remember, that's where we have to have our orientation of as we go from left to right. So as I go from left to right, if I was to trace this curve, I'm actually going down until I get to somewhere about here, and then I start to go up. So the arrow just tells me that the graph continues in that direction, but I can't use the arrow to help me determine increasing versus decreasing. Okay, so now we're going to actually apply this to parabolas, because that's what we're dealing with here. So I have a picture of a quadratic function here, and although there are not arrows, I am assuming that this continues on, and this one will be the same when we get to that as well, right? So first thing, we want to identify the vertex. I can see my vertex is right here. Where is that? That's at 3, -5. Then we want to identify the axis of symmetry, which I know goes through the vertex. So this is x equals 3. Now, this is where we get into some new stuff. So maximum or minimum. So would you describe the vertex here as a minimum point or a maximum point? And what you want to think about is it the lowest point on the graph or is it the highest point on the graph? Would you describe it as the bottom or would you describe it as the top? I would describe this as the bottom or the lowest point on the graph, and so this is a minimum. What is the maximum or the minimum value? That is the y-coordinate of the vertex. So that is -5, and I'm getting that from this. The domain, so notice that this graph, although it's going up, it is also continuing to go to the left. And here it's going up, but it is also continuing to go to the right. And it is including everything in between. And so the domain, and this is actually true for every quadratic function, the domain is going to be -infinity to infinity. The range, remember, is the y-coordinates. And we always want to go from lowest to highest, or bottom to top. Well, we know we have a minimum value, and we know what that minimum value is. And then from that, the graph goes up forever. So the range is going to be -5 to infinity. And this -5 is the same -5 here. Okay? Now, a couple of notation things. Interval notation. So remember, parentheses means that we are not including the number, and infinity and -infinity are not numbers, so we don't ever include them. The bracket means that we are including it. Think of it as like a greater than or equal symbol versus a greater than symbol. So -5 is a value on this function in the y values. So that is included. So that's why we use the bracket there. Now, increasing. So here is where we have to think about what we talked about before. Increasing, as I go from left to right, am I going up or am I going down? So first I start by going down, then I hit the minimum, and then I go up. So what we're going to see is that the minimum point, if there's a minimum point, is always going to be where we change from increasing to decreasing or decreasing to increasing. So I'm increasing from 3 to infinity. And hold your questions for one sec. I'm going to do the decreasing, and then we're going to talk about it. The decreasing is this side. So I'm decreasing from negative infinity to 3. Now, you might be asking yourself, where is that coming up? Or where are we coming up with that? That is always x values. So remember I said for increasing and decreasing, we have to read it from left to right so that we have an orientation of what is up versus down. Then, since we are reading it from left to right, we write our answers of our intervals in terms of the x coordinates. This should always match up with the entire domain. So the domain is negative infinity to infinity. So one of these intervals should start at negative infinity, and one of them should end at infinity. Wherever one of the intervals ends, another interval should start at that same location. Notice here that I'm using parentheses because although 3 is an included value in the function, at this point, 3, negative 5, that is when we have our minimum. So at that exact point, the function is not increasing or decreasing, it's just the lowest point. So it is decreasing on this interval from negative infinity to 3, and then from 3 to infinity, it's increasing. Okay, I want you to try and do the next one. Answer all the questions, do the best you can, pause the video, unpause when you're ready to check. Alright, so here's the information I got. So our vertex is at negative 4, 3. And we can see that because that's this point right here. The axis of symmetry then is x equals negative 4. That's our axis of symmetry. I didn't actually draw it in. This is a maximum point because I would describe this as the highest point on the graph, right? If you just think about this shape, we can think of it as like a hill, right? This is the highest point, it's a maximum. So what is the maximum value? That is the y-coordinate of the vertex, just like we had here. The domain is always all real numbers or negative infinity to infinity since it's a quadratic function. Another way to think about that is this is going to go to the left forever, this is going to go to the right forever, and we include everything in between. The range, remember we always go lowest to highest. So since this is a maximum and these are going down then, the lowest this graph is going to go is it's going to go negative infinity. So the range is going to start at negative infinity, and then it's going to go to the highest y-coordinate. The highest y-coordinate is 3, but that is included on the function. Then the increasing and decreasing, so as I go from left to right, the graph is going up, so it's increasing from negative infinity to negative 4. Remember, these are based on x values, so the domain, negative infinity, negative 4. And then it is decreasing from negative 4 to infinity. And again, that's based on the same x values, so this negative 4 matches up with that negative 4, this infinity matches up with the domain. Okay, so this last part here, I'm going to go through this a little bit quickly before we do more examples, because if you understood the last examples, then this isn't really something you need to really write down necessarily, but again, it's something you would see in a textbook or if you search online to try to help you with increasing and decreasing. So if we take our quadratic function in ABC form, ax squared plus bx plus c, the y-coordinate of the vertex is the minimum value. We talked about that. And that is if a is positive, because if a is positive, then it opens up and it has a minimum. And then it's the maximum value if a is negative, because then it has a maximum. The rest of this stuff is things that we've talked about before. The vertex is the point hk. We find h by doing the opposite of b over 2a. We find k by plugging in h to the function, or by plugging in opposite of b over 2a to the function. That's the same thing, it's just two different ways to write the same notation. The domain is negative infinity to infinity. The minimum or the maximum value are going to be k. If it's a minimum value, then the range is k to infinity. Your decreasing intervals will be negative infinity h, and increasing will be h to infinity. Again, we saw that on the last example. And then if it's a maximum, the range is negative infinity to k. Decreasing intervals are h to infinity, and increasing are negative infinity to h. These aren't things to memorize, just understand what it means to be increasing and decreasing.